Have you ever noticed something strange about photos from space? They're real, but there's one thing missing: stars. Whether it's rocket launches, moon landings, or videos from the International Space Station, the background is always pitch black. This has sparked some wild conspiracy theories. But what's really going on? According to experts familiar with space photography, it's not a cover-up. It's all about how cameras work and what astronauts actually see up there. The sky isn't just dark, it's this deep, almost tangible blackness that feels like you could reach out and touch it. Take the famous 1984 Challenger mission, for example. Astronaut Bruce McCandless made history with the first untethered spacewalk. The photo of that moment is iconic. But something's missing: stars. Why? Well, it's not the camera's fault. Evidence points to the way exposure works, both in cameras and our own eyes. When you look at space images, the stars are nowhere to be found. It's not just one or two photos, it's almost every single one. From moon landings to ISS footage, the background is just a void. This has led some to question whether we're being told the whole truth. But according to sources close to NASA, there's a simple explanation. Cameras in space are set up to capture bright objects, like astronauts, the moon, or Earth. Stars, on the other hand, are incredibly dim in comparison. Trying to expose both in the same shot, it's nearly impossible. Astronauts have reportedly described the sky as an inky blackness, almost like a texture you could sink your hand into. So, it's not just the cameras, it's what they're seeing too. The stars are there, but they're drowned out by the brightness of everything else. On February 7th, 1984, the Challenger space shuttle made history. Astronaut Bruce McCandless stepped out for the first untethered spacewalk, floating freely in the void. The moment was captured in a now famous photo. But something's off: no stars. According to an expert familiar with the mission, the camera settings were adjusted to capture McCandless and the shuttle, not the faint light of distant stars. The astronauts themselves allegedly described the sky as a deep, textured black, almost like a void you could fall into. This isn't unique to the Challenger mission. Evidence suggests that in almost every spacewalk or lunar landing photo, the stars are missing for the same reason. It's not a conspiracy, it's just how cameras and human eyes work in such extreme lighting conditions. Cameras, whether in space or on Earth, rely on exposure settings to capture light. The shutter speed determines how long the sensor is exposed to light. In space, the bright objects, like the sunlit Earth or a spacecraft, require shorter exposures to avoid overexposure. Stars, on the other hand, are incredibly faint. To capture them, you'd need a long exposure, which would completely wash out the brighter objects in the foreground. According to sources close to NASA, this is why stars are rarely seen in space photos. It's not that the stars aren't there, it's just that the camera settings prioritize the brighter subjects. This isn't unique to space photography. Even on Earth, capturing both a bright foreground and a starry sky in one shot is nearly impossible without specialized equipment. Astronauts have reportedly described the view from space as a deep, almost overwhelming blackness. According to accounts from those who've been there, the sky isn't filled with twinkling stars like we might expect. Instead, it's a vast, textured void. This is because human eyes, like cameras, adjust to the brightest light in the environment. On the moon or in orbit, the sunlit surfaces are so bright that our pupils shrink, making it nearly impossible to see the faint light of stars. However, there's a catch. If astronauts move into a shadow, like the shadow of the lunar lander, and let their eyes adjust, the stars slowly become visible. This suggests that the stars are always there. It's just a matter of perspective and lighting. During the Apollo missions, astronauts allegedly couldn't see stars from the moon's surface during the day. The bright sunlight reflecting off the lunar landscape made it impossible for their eyes to pick up the faint light of distant stars. But according to sources close to the mission, there was one exception. When astronauts stood in the shadow of the lunar lander, their eyes had time to adjust to the darkness. Slowly, the stars began to appear, revealing the universe in all its glory. This raises an interesting question. What will future astronauts see when they return to the moon? With plans to land at the darker lunar South Pole, they might have a better chance of seeing the stars if they can escape the glare of the sunlit surface. Our eyes are like tiny cameras, adjusting to light by dilating or contracting the pupils. In bright environments, like the moon's surface, our pupils shrink to block out excess light. This makes it nearly impossible to see faint objects like stars. According to experts familiar with human vision, this is why astronauts on the moon or the ISS reportedly couldn't see stars with their naked eyes. Their eyes were adjusted for the bright surroundings, effectively blinding them to the dimmer light of the stars. But in darker areas, Like the shadow of the lunar lander, their eyes could adjust, allowing the stars to become visible. This suggests that the stars are always there. It's just a matter of how our eyes and cameras are set up to perceive them. When the Artemis missions return to the moon, astronauts will land at the lunar South Pole, a region that's much darker than previous landing sites. This raises the question, will they see more stars? According to sources close to the mission, the answer is maybe. While the South Pole is darker, the sunlit areas will still be incredibly bright, making it difficult to see stars without proper adjustments. However, if astronauts spend time in the permanently shadowed craters, they might get a breathtaking view of the universe, unobstructed by light pollution or Earth's atmosphere. It's a tantalizing possibility for future explorers. While most space photos don't show stars, there are exceptions. Astronaut Don Pettit, for example, has reportedly captured stunning long-exposure images of stars from the ISS. These photos prove that stars are indeed visible in space, if you know how to capture them. According to experts familiar with astrophotography, long exposures allow the camera to collect enough light from faint stars, creating those breathtaking images. This technique isn't new, but it's not typically used during missions focused on other tasks. Pettit's work shows that with the right settings, the stars can be revealed. It's a reminder that the absence of stars in most space photos isn't a conspiracy, it's just a matter of how the camera is used. The idea that stars are missing from space photos because of a conspiracy doesn't hold up under scrutiny. According to experts, the explanation is much simpler. It's all about exposure. Cameras and human eyes prioritize the brightest objects in the frame, whether it's an astronaut, the moon, or Earth. Stars, being much dimmer, get lost in the process. This isn't unique to space, it's a basic principle of photography. So, the next time someone claims that the lack of stars in space photos is proof of a cover-up, you'll know the real reason. It's not a conspiracy, it's just science. So, why are there no stars in space photos? It's not a mystery or a cover-up. It's all about how cameras and human eyes work. Bright objects like the Earth or a spacecraft dominate the frame, leaving the faint light of stars invisible. But with the right techniques, like long exposure photography, the stars can be revealed. And when future astronauts return to the moon, they might get an even clearer view of the universe from the darker lunar South Pole. The next time someone brings up this conspiracy, you'll have the facts to set the record straight. Space is full of wonders, and the stars are always there, even if we can't always see them.